I'm Niveta. In this video, we are going to see the continuation of the sequence. Okay, so in this video, we are going to see about a convergent sequence and a divergent sequence and many type of sequence. A sequence is said to be a convergent sequence if limit of the sequence exists. Okay, there should be one value. Okay, for that. What to say, the sequence is said to be a convergence if limit of the sequence should end in one particular value, right? Actually the sequence goes on, but we have to consider there is a point where the sequence ends. If that point exists means it is known as convergent sequence. See here, limit n tends to infinity, a n is equal to L. Here n tends to infinity, it approaches to infinity, that value is equal to n means the sequence converges to L. Okay, here limit n tends to infinity, 1 by n is equal to 0, because if you put infinity, no, 1 by infinity is equal to 0. There is one point which is L, it exists, so it converges to 0. Understood? Results of convergent sequence. Every convergent sequence has a unique limit point. So for every convergent sequence, suppose if you are saying one sequence is a convergent sequence, then that sequence has a unique means what? We should not say 2 3 or something. That's a unique limit point should be there. Okay, a sequence cannot converges to more than one point. We can't say that the sequence converges to 2 points or 3 points. Okay, the sequence should converges to only one point, that is unique. Every convergent sequence is bounded, the converse is not true. Suppose if you are considering a convergent sequence, okay, convergent sequence means it ends by one particular number. So convergent sequence should be bounded. Okay, bounded means what to say, it should be ended. Okay, the converse need not to be true. Suppose if you are considering a bounded sequence, then it should be a convergent. No, that doesn't exist. But convergent sequence is a bounded sequence. Just remember A, B, C. Okay, to to come to C, you have to cross B, right? Right. So for convergent sequence, it's bounded. Okay, you can't go from this to this. ABC should come like this, right? So for this convergent, you must have reached B only. After that only you will get C. So you can't go by reverse order. Likewise, you just remember every convergent sequence is bounded, but not every bounded sequence is a convergent sequence. Okay, the sequence an is defined by an is equal to minus 1 power n. Clearly the sequence is bounded. Okay, so bounded means what? Suppose if you are putting, you will get minus 1. If you are putting 2, you will get 1. Putting 3, you will get minus 1. Putting 4, you will get 1. Okay, it is a bounded sequence. Okay, the greatest lower bound. The greatest lower bound is what? Minus 1. Here this is the greatest lower bound and 1 is the least upper bound. Okay, but it is not convergent, because convergent should have unique limit point, I told earlier, right? Here we are having two values, so it is not convergent. Okay, null sequence. An is said to be a null sequence if it converges to 0. See, limit n tends to infinity, an value is equal to 0 means then it is a null sequence. Example for this is 1 by n square, 1 by 2 power n or null sequence. If you are putting infinity, no, so 1 by infinity is equal to 0. When you are getting the limit point as 0, you should say like that is null sequence. Okay. Next we are going to see cauchy sequence. A sequence an is said to be a cauchy sequence. Cauchy sequence means convergent sequence. When you will say a sequence is a cauchy sequence means epsilon greater than 0, however small, there exists a positive integer n depending upon epsilon such that an minus am, okay, an minus am is less than epsilon. So what they are telling is so in last video itself I have discussed about the limit point of the sequence. Okay, so same like this. What I have to say, like here you are having 1 2 3 4 values. Okay, at one particular point you will exist a point m. So consider a sequence an. Okay, consider a sequence an. Okay, consider another sequence am. Suppose I am considering a sequence am here. Okay, consider a sequence an and I am considering another sequence am. The distance between am and an should be less than infinity. It should be very small. The distance is very, very small. Okay, the distance between this sequence an and this sequence am should be very less than epsilon. When that exists, after this particular point, okay, after this particular point, for all numbers the distance between will be less than epsilon. Okay, after this particular point, not before this point, after this particular point, the distance between this sequence and this sequence will be less than epsilon. See the definition now. A sequence an is said to be a cauchy sequence for given epsilon greater than 0. However small, there exists a positive integer m. I told you, right, there is one positive integer m depending on epsilon, such that the distance between an and am should be less than epsilon for n is greater than m. N means this an is, right, so this an should be greater than m. Okay, so after this m only, these two numbers, the distance between the sequence of the numbers will be less than epsilon. Okay, so another definition, a sequence an is said to be a cauchy sequence if for a given epsilon greater than 0. Epsilon is a very small quantity, but that quantity is a positive quantity. Okay, however small, there exists a positive integer m. I told you, right, such that am plus p minus am. See, there are two sequences existing. Okay, am plus p, suppose if you are considering am plus p means this is a sequence am plus p, this is a sequence of am. Okay, after one particular point, the distance between these two sequences will be less than epsilon. Am plus a modulus of am plus p minus am is less than epsilon. For p greater than 0, p belongs to natural number. Understood? So here an minus am is less than epsilon also you can tell, or modulus of am plus p minus am is less than epsilon also you can tell. A sequence is convergent if and only if it is a cauchy sequence. Cauchy sequence is a convergent sequence. Every convergent sequence is said to be a cauchy sequence. Cauchy sequence is always bounded. Understood? Next, divergent sequence. A monotonic. Monotonic means what? Continuously increasing or decreasing. A monotonic and unbounded sequence. We can't tell the end point. Okay, so that is known as divergent sequence. So an is equal to n is an example of divergent sequence, because if you put 1 2 3 4 5, it goes till infinity, right? So it is a divergent sequence. Oscillatory sequence means it will not converge as well as diverge. Okay, and neither converges to a finite number or diverges to plus or minus infinity. Okay, then it is called oscillatory. Oscillatory means the example is given like minus 1 power n means it's like minus 1 1 minus 1 1 minus 1 1. So we can't tell uniquely the point which converges, as well as we can't tell it diverges to plus or minus infinity. Understood? Then the unbounded sequence which does not diverge. So there is one unbounded sequence. Okay, it will not diverge also. Is said to be oscillate infinitely. Suppose if you are putting 1 means you will get like what? Minus 1. If you are putting 2, like you will get 2. If you are putting 3, like you will get minus 3. If you are putting 4, like you will get plus 4, right? So it one time it will be like minus 1, it will be like 2, next minus 3, it will be like 4. So it oscillates here and there, so it oscillates infinitely. Understood? Next, subsequence. Subsequence means an be the given sequence. Okay, nk is strictly increasing sequence of a natural number. n1 is less than n2 is less than n3. Then ank is a subsequence of an. So ank is a subsequence of an means what? An is a sequence. Nk is a strictly increasing of natural numbers. Okay, suppose if you are considering a sequence like this. Okay, then nk is, so you have to consider one part. Okay, you have to consider one part. Nk is a strictly increasing sequence that should be increasing, that is n1 is less than n2 up to it goes on. an is equal to minus 1 power n. A power 2n is equal to 1, a power 3n is equal to minus 1, or the subsequence. See here, this is one sequence. We are separating it by a2n, which is for every even number it comes like 1, right? I already told you, when you put 1 you will get minus 1, when you put 2 you will get 1. So minus 1, 1, minus 1, 1, minus 1, 1, it goes on like that. So for 1 you have to put like even numbers, for minus 1 you have to put like odd numbers. Okay, so we are just dividing this one particular sequence into two sequence, that is known as subsequence. Okay, results on subsequence. Every sequence is a subsequence of itself. If you are considering one sequence, no, that same sequence is a subsequence of itself. If a sequence an converges to L, then every subsequence also converges to L. Or one particular sequence converges to L means that subsequence also converges to L. If all the subsequence converges to the same limit, then an converges to L. See, there are so many subsequence we can consider. All the subsequence, okay, converges to the same limit L means that that actual sequence also converges to L. If the subsequence a2n minus 1 and a2n of the sequence converges to the same limit, then the sequence converges to L. See, we are dividing that sequence an into two types, a2n minus 1 and a2n. Okay, so this two sequence converges to a particular limit L means that the whole sequence will converge to L. Okay, fine. Suppose an diverges to infinity means subsequence also diverges to infinity. If an that sequence diverges to minus infinity means subsequence diverges to minus infinity. Every sequence contains a monotonic subsequence. Monotonic means it should be like one suppose it should be like increasing or it should be like decreasing. It should not be like both increasing as well as decreasing. Okay, that is what monotonic. Every bounded sequence in R contains a convergent subsequence. Every bounded sequence, if you are considering a bounded sequence in the real number, it will be like convergent subsequence. It has a convergent subsequence. Okay, here they are telling about the sequence, here they are telling about the subsequence. Results of sequence. A monotonic sequence is convergent if and only if it is bounded. See here, already what we have seen is a cauchy I already told you like a sequence is convergent if and only if it is a cauchy sequence, right? Another point I told you like every convergent sequence is bounded, but the converse is not true. What does that means? Every convergent sequence is a bounded sequence, but not all bounded sequence is a convergent sequence, right? But what they have given is a monotonic sequence is convergence if and only if it is bounded. If and only if means this side also comes, this side also comes. How that possible? I already told you, not every bounded sequence is a convergent sequence. See here, monotonic word changes everything. Monotonic word means what? It is increasing or it is decreasing. So if it is increasing means it converges to a point means it is bounded. It is bounded means it is convergent. Okay, here also it is bounded like this means a monotonic sequence, decreasing sequence is convergent means it is bounded. If it is bounded means it is convergent. Okay, a convergent sequence need not to be a monotonic. Okay, so suppose if you are considering a convergent sequence, it need not to be monotonic, always need not to be monotonic. Okay, so it may or may not be monotonic. Suppose if you are considering 1 here, you will get minus 1. 2 here, you will get 1 by 2. When you are getting 3, it minus 1 by 3. When you are getting 4, it's like 1 by 4. Right. So this also converges to a particular limit, because when you put infinity, no, you will get like 0. Okay, so it is a convergent sequence, but it is not monotonic. The both minus number as well as plus number comes alternatively, right? Next, monotonic sequence can have almost one limit point. I already told you monotonic sequence means it has only one limit point. Here also monotonic decreasing means it has one at most means at most